All right, so we want to be able to go back and forth between these two formats. And so we're going to try to convert from one to the other. And so let's try to take this as in slope intercept. Let's try to turn it to general form. So we do that by, general form has x's and y's both on one side. So let's try to put both x and y on the same side to begin with. So I'm going to rewrite it. I'm going to try to get x's and y's both on the same side. So let's add 1/4 x to both sides. Like that. You end up with y plus 1/4 x. Doesn't really matter what order they go in. Equals 3/4. It's pretty good, but I want whole number, whole number, whole number. And so to get whole numbers, let's multiply everything by 4. When we do that, we'll get 4 y's. 1/4 x times 4 gives you 1 whole x. And 3/4 times 4, those cancel out, and you're just left with 3. And now it's in standard form, whole number, whole number, whole number. Right? If you're really being a dork, you can put 1x equals 3, and that's fine too. Okay, so let's try that. We're going to do the same thing. We're going to do the same thing with this, but backwards. We're going to take that and try to turn it into slope intercept. The slope intercept looks like x's and constants on one side. So I'm going to write it down. And now I'm trying to isolate this y. So basically, I'm targeting this y to be all by himself, just like that. So let's first subtract 2x from both sides. I'm just being strategic. I'm going to leave this as 5y. Those cancel out. This ends up being negative 2x plus 7. All right, don't freak out. The negative 2x is still negative 2x. The positive 7 is still 7. So far so good, but I want this y by itself. So let's divide by 5, divide by 5, divide by 5. Right? Everybody gets divided by 5. So this ends up being y. This is negative 2/5 x, because 2 times x divided by 5 is the same as 2 divided by 5 times x. And this is 5/7. Cool. Now, if you were to graph that, you'd start at 5/7, wherever that is. It's what? It's 1 and 2/5. Doesn't really matter. And you'd go down 2 and over 5. So you'd go down 1, 2, and over 1, 2, 3, 4, 5. You'd draw your next line, and you'd go like that. It'd be fine. It's a little bit ugly to graph because of the fractions, but you still could. Cool. All right. Then, what else? I think the last part of this that we want you to be able to do is figure out whether a point actually lies on a line. So you'll get a line like that, and you want to see, does this point lie on it? Now, it's really easy to see if it's visual, so you could plot the points and see, but I can't always plot the points, so let's try to do it graphically. An equation takes an x and a y value and makes them true. So if we're trying to see if this point lies on this line, we could take the x and put it in for that x, and take this y and put it in for this y, and see if it makes it true. So do you get 7 when into the 2 you put a 3 and you add 1? This is 6, this is plus 1, this 7 equals 7. Sure does. It doesn't exactly matter what you get here, just that you get a true statement. So let's try the value to 4, right? Do you get a 4 out when you put a 2 into the equation? Right, so I'm trying to get a 4 out. I put a 2 in. This is 4, this is 5. Does 4 equal 5? No. So 4 doesn't lie on the line. You can play the same game even if it's in standard form. You put in the x, you put in the y, and you see if it's true. So this is 5 times 4 plus 3 times negative 2. And I want to get 16 out of it. Right, so I put the x in for the x and the y in for the y, and I see if I get a true statement. This is 20 minus 6 equals 16. Is that true? No, that's 14. Does 14 equal 16? Heck no. So this point doesn't lie on the line. Where is it? I don't know, just not on the line. And we can use this concept to like solve more complex problems. So find C, given that this point does lie on the line with some equation. So essentially what we're doing is, look, here's a -5, 2. Well, I guess we'll do it algebraically. I know that y equals 4x plus c is a line. I'm not sure what c is, but I know that this x value and this y value make this true. So you could put -2 in for the x. You could put the -5 in for the y, because I know that's true. And the thing that I don't know is c, so you could solve for c. This ends up being -2 and -20 plus c. You would solve by adding 20 to both sides. You'd add 20 to this and you'd get, oh, positive, sorry, 18 is c. So then that's the c value that we want to use in here. So you can say y equals 4x plus 18. And if you checked it, if you put in this x value and this y value into x and y, you should get a true statement. Cool? You try that for this one. See if you can pause me, put x and y in, and solve for k. Okay, so that's an x and a y. So this is 3 times the x value minus 2 times the y value. Should give us k. Let's solve for k. This is 12 minus 14 equals k. This is -2. Should be k. Yeah? How do we do? Yeah, -2 and 18. Great, we did it. All right. Let's see. I guess this is the last part of it. Horizontal and vertical lines have really specific equations that are easy to follow. For example, if you took this line, let's give it right here. Sorry about all the other lines. This point is 1, 1. This point is 1, 2, 3, 1. This point is 5, 1. This point, 1, 2, 3, 4, is -4, 1. It's horizontal, so what you notice is only thing that's changing is x. The thing that's not changing is that y value is always 1, right? So the equation for this is y value is 1. That gives you the equation of this horizontal line. They play by a little bit of a different rule. And if your line was up here, or if your line was up here at there, it would be the exact same, except this would be 1, 1, 2, 3. So this would be up at 3. And this would be 3, 1, 2, 3. This would be up at 3. And 5, 3. And -4, 3. And this equation would be y equals 3, right? Because it's up here at 3. So these blue lines, this blue line, the equation of it is y equals 4, because it's all of the points are 1, 2, 3, 4 for their y coordinate, right? This is 0, 4. This is -2, 4. This is -1 billion, 4. That's not a billion. You get the idea, right? Similarly, this equation is y equals -1 because all the y values are -1. Cool? The same thing goes with vertical lines. Their equations are easy to write. They're just different than we expect them to look. This point is 2 over 0 up. This is 2 over 2 up. This is 2 over 5 up. This is 2 over -2 up. What's the same in all of them is the x value is 2. X value is 2, x value is 2, x value is 2. Lo and behold, the equation is x equals 2 because it's always 2 in that line. The x is always 2. Similarly, this is negative 3, 0, negative 3, 2, negative 3, 5. What's the same in all of these is that the x value is negative 3, and that's the equation of that vertical line. Cool? So vertical lines have x equals whatever, x equals a number, and horizontal lines have y equals a number. Cool? Try those out. You got plenty of stuff to work with for home learning. The answers are on the back. Try those, and I'll see you later.